Hello. Today we are going to discuss about the limits concept. So generally, when it comes to the limits, which is the topic, you can see it in intermediate. When it comes to the problems of limits, the limits problems are very easy actually. If you have basic mathematical skills, of if you know the best simplification, I mean, if you are very good at simplification, then doing this limits problem is not a difficult thing at all. But the intention of introducing the limits is not just to simplify and get the answer. It has a big scope. So, I mean, the real introduction, the main importance, the application of limits is not actually just to solve the problems. There is a lot of concept, a lot of the vast things or great things. We cannot say great things or something, but it is a big concept. So because mostly the children of intermediate will focus only to solve the problems. Solving a problem will, just makes you to helps you to get the marks. But actually, if you understand the concept, then you will enjoy it, and you will also feel you will feel that okay, I learned because of this reason, I learned because of this application. Because if you find the application, if you find the meaning out of the application, then that's actually said to be a complete education. So I will try to give a little I'll try to give a focus on a real way of understanding. I don't want to say the real term. Actually, that is the actual way to learn the limits. That is how we need to learn it. But I don't want to comment on that. That's fine. So limits. Limit. Limit is a word we'll use in general life. For example, hello, be in your limits. Okay, even for doing the good things, you need to, there is a limit for doing the good things, there is a limit for doing the bad things. So in this way we'll use the word limit. For example, okay, be in your limits. Okay, I said some of the examples related to the limits. So all this, how the general limit is really, the meaning of general limit. See, limit is a word we'll use in general life, and same limit word we are also using in mathematics. So, how this general limit meaning is connected to mathematics? So, our focus is mostly how the general way of, our focus is the first focus. What I wanted to do is I wanted to connect the general limit word meaning to mathematical limit, mathematics limit. See, if you understand the real world, it will not be in numbers, but you will try to understand the real world in mathematics. Just to connect my statement, just to justify my statement, I would like to take a small example. Let us assume a customer went to a shop and purchased three apples and two oranges, and the shopkeeper said the price for these is 50 rupees. So if you look at this one, here this statement actually talking about three apples and two oranges. So and the price is 50 rupees. It seems to be like a very English statement, but we can find a mathematical out of it. We can express the same thing in terms of mathematical language. How? For example, let us assume the price of apple is X and the price of orange is Y. Then it's going to be one apple price is 1x rupees, three apple prices is 3x rupees, one orange price is y rupees, two oranges price is 2y rupees. So the equation is going to be turned out into the form of 3x plus 2y is equal to 50. See, 3x plus 2y is equal to 50 is same as a customer went to a shop and purchased three apples and two oranges, and the total price is 50 rupees. So what exactly we are doing it? We are trying to convert the real life situations or real life things, real normal general language into a mathematical language. In the same way, we can also understand the concept of limit in mathematics. So let us try to understand. I mean, it will take some time to understand it, but to understand this, okay, to understand this, we need a small, what we can say, we need a small prerequisite to understand the concept of limit. We need to have a prerequisite, some eligibility, or we cannot say eligibility. I can say that this is the information, few things that you need to know it to get the best understanding of limits. Even without that, we can do it, but still, that gives the best understanding. Okay, so if you look at the limits, uh, okay, so let's try to uh, actually, what is the main application of main reason for introducing a limit? What is the, I mean, what made us to think about the limits? Why the mathematics is focusing, done a lot of research and made these volumes of books to introduce the limits? So let us take some examples. I think these examples are going to help you to understand the concept of limit in a better way. So let's try to take that example. Okay, so my intention is the reason, or we can say why limits. Why, I mean, what is the reason for bringing the concept of limits, or what motivated us to think about limits or to research on the limits. Okay, so let us start. See, I would like to take a function, I would like to define a function f of x. Okay, generally the functions are represented with f of x. What do you mean by this? A function which is in the form of x terms. Okay, let's take this as a function f of x. Now I would like to take a small example, x minus 3 by x minus 3. So this is a function. If you look at this function, if you look at this function, what is the first idea that will come into your mind? See, x minus 3 numerator, x minus 3 denominator. Both numerator and denominators are same. So our first idea, or the first prediction, what is going to happen? The result is always going to be 1. This is what you feel, and this is what some of the inputs will give. Okay, for example, let's try to keep x value 1. If I keep x value as 1, then it's going to be 1 minus 3 by 1 minus 3. So 1 minus 3 is minus 2, 1 minus 3 is minus 2, minus 2 by minus 2 is 1. So it's going to produce, I mean, x at x is equals to 1, f of x value is what? This is actually f of x value. I mean, f of x, that means f of 1. You can keep f of x also, but in place of x we are keeping 1. So therefore this value f of 1, f of 1 value is going to be what? 1. That is what the meaning of f of this one. So it is giving 1. Now let's try to place at x is equals to 2. So if I place x is equals to 2, then this f of x is going to become f of 2, and this is going to be 2 minus 3 by 2 minus 3, which is once again going to become minus 1 by minus 1, which gives the result 1. See, you don't need to do the calculations to find the answer or to understand the answer. The same number, if you divide with the same number, it's always 1. But is it true for every number? Generally, it feels like it is true for every number. Okay? For example, 30 by 30, 3 by 3, 1 by 1, 2 by 2. For every number, it seems to be the result is always going to be 1. But just imagine what happens. This is the question even Ramanujan been asked to his teacher at the time of his class, some class. So what happens if 0 by 0? Is it also gives 1? No, it's not going to give 1. the same situation or the same incident, same occurrence is going to happen when I'm going to place at x is equals to 3. For example, if I place x is equals to 3, okay, what is going to happen? This f of x value is going to be 3 minus 3 by 3 minus 3. This is actually 3 minus 3 is 0. This is 0. 0 by 0 is what? This is indeterminate. You cannot find it. You cannot find the value of uh, value of f of x at x is equals to 3. So at x is equals to 3, this function is undefined. We cannot say indeterminate, or you can say undefined. So this is where the limits are going to place an important role. Okay, so what is this form? This is a indeterminate form, undefined form. Okay, and some people also, I mean, we can say it is infinite form. Okay, so now this is where the limits concept, this is where the scope of limit or the picture of limit will come. So see, at x is equals to 3, this is indeterminate, but at x is equals to 2.9, at x is equals to 2.99, at x is equals to 2.999, at x is equals to 2.99999. So if I just close to 3, I mean not going to the 3 but nearest to 3, if I take the values, then it is going to give some kind of values, right? Okay, let's see. Okay, let us take x is equals to, I'm not taking 3 but I wanted to try with 2.9. So what is your f of x? F of x is going to be 2.9 minus 3 by, which is 2.9 minus 3. Okay, so what is going to happen? This is 0 0.1 by 0 0.1, that's going to be 1. Next, at x is equals to 2.99, then what is the x value? Okay, it's going to be 2.99 minus 3 by 2.99 minus 3. So that's again going to be 0 0.01, right? So 3, we can write 3.00, 2.99. Sorry, 0.01 by 0.01. So once again it is going to become 0. So actually you are taking 2.9, 2.99, even for 2.99, okay, 2.99, 2.999. Okay, what exactly we are doing is, okay, we are actually at x is equals to 3, it is indeterminate, but at x is equals to 2.9, it is giving 1. At x is equal to 2.99, also it is giving 1. At x is equals to 2.999, we are going very closer to the infinite. For example, if you draw a graph of this thing, okay, let us assume this is a linear equation. Maybe you are going to get a graph like this. Let's take the graph here. Okay, so it's always going to be 1. So it's going to be like this. It's going to be, so this is 1 and this is 2, 1, 2. But at 3, is it going to give a value? Is it going to give a value? So this is where a breakdown will happen, and that breakdown will generally represent with a circle, with a hole. So what do you mean by this? At every point 1, it is defined, it gives 1. At 2, it is defined, whose value is 1. At 2, it is gives 1. At 2.9, also it gives a value, that is 1. 2.99. See, actually this is an undetermined or undefined value. Okay, now we are taking a value which is very closer to 2.9. Even 2.9 is also giving 1. 2.99 is also going to give 1. So every value which is, every value that you are taking nearest to 2, 3 is actually you are going towards the undefined. I mean, when you go like this, what you are trying to do, your value, your x value, you are taking very closer to 3. By taking the x value very close to the 3, okay, you're trying, I mean, you're coming very close to the infinite. So we can say that we are trying to, I mean, using a concept of limit, we are trying to find the nearest infinite value or the nearest undefined value. So this is the main introduction. Okay, now after 3, for example, after 3, let's take this is 3.1, 3.1, 3.1. Okay, if you take 2.9, your value is what? 1. Let us also take 3.1. So what is the value? F of x is equals to 3.1 minus 3 by 3.1 minus 3. So this is going to be how much? 0.1 by 0.1, which is going to give 1. So same way, if I take 3.01, what is going to happen? F of x is going to be 3.01 minus 3 sorry, by 3.01 minus 3. So even that is also going to be 0.01 by 0.01. So what exactly is happening? Okay, even at 3.1, if you go little closer to 3.01, if you take 3.01 and more, I mean, if you are, what exactly you are trying to take? 2.9, maybe imagine it is at here 2.99, which is even more close to here. 2.99, that is even more close to here, even more close to here. It's actually going very close to 3, but not actually meeting the 3. So using the concept of limit, actually we are trying to find the best way to define at 3 also. So this is the main advantage. I mean, at undefined, this is undefined, this place is undefined. We are closing very close to, I mean, we are going very close to 3, and we are trying to determine the value of that at very close, what it is going to happen. So that value, I mean, to find that value, we are actually using a concept of limit. So what exactly we are doing is, okay, nearing to 3, okay, we are taking some values which are very close to 3, very close to 3, close to 3 from left hand side, close to 3 from right hand side. Okay, so we are taking this and we are trying to define the value at 3. Okay, at 3 it is not possible, but if it is possible, I mean, if you can take that, what is going to happen? So that is what, I mean, if the x is trying to reach to 3, if the x is trying to reach from left side and from right side, so where this f of x will reach? So that is what the main application and usage of the limits. Okay, so what exactly we are trying to do? We are trying to do, or we are trying to define, or we are trying to, in fact we can say, we are trying to find the limit for an infinite. There is no limit for an infinite, but even we are trying to define, or even, what do you mean by definition? So definition is nothing but what? We are actually limit few things. We will give some conditions. Actually we are giving some limits, and based on that limits we will define it. Same way we are trying to define the undefined things with the help of this limit. So we are limiting the infinite, we are limiting the undefined things, we are limiting the indeterminate things, and we are trying to define it. So that is the main application and usage of the limits. Okay, so I hope I have tried to convey the message what I wanted to do. And so this is the main reason for, I mean, not just 0 by 0 form in a calculations. Okay, and some, there are some functions which also gives something called infinite by infinite. Okay, even infinite by infinite is the indeterminate form, we cannot find it. So those things are also going to be understood, or we can say those things are also going to be understood or to be measured with the help of limits. Next, we have something called infinite minus infinite. There are some places, so this is one indeterminate form. Like that, there are different, I mean, we have the indeterminate forms in different forms. Sorry, yeah, different forms. And this is one form, 0 by 0. Infinite by infinite is another form. Infinite minus infinite, another form. Like infinite power, okay, infinite power 0, this is also one form. Next, 0 power 0, this is also one infinite form, I mean indeterminate form. Next, something called uh, infinite infinite whole power infinite, this is also something. Okay, next, we have something called uh, what is that, 0 by infinite. So like that we have different indeterminate forms. All these are indeterminate forms. I'm sorry. Yeah, 0 by infinity. So we have different types of indeterminate form. So with the help of limits concept, we are going to determine, or we are going to understand these indeterminate things. So this is the main objective, or you can say an application of indeterminate. Okay, now I'll take up some other things. So this is the whole idea of this chapter. If you look at any kind of problem, it's almost we are going to deal this. But there are some problems, I mean in a textbook you can see the problems where you will simply substitute the value and get the limits. So that is simply a substitution in getting the answer. That's not the real core, what we can say, that is not the real application or the importance of limits. Okay, so that's all.